And I'm recording as well. So the recording has now started. For those of you joining us late in the movie, we just covered a little bit of the background on why and the motivation behind these two new microservices. So as I was saying, the motivation behind Crunchy Spatial is they're intended to be modern, lightweight mapping services optimized to work directly with PostGIS. I'm going to foot stomp that a couple of different times throughout this presentation. They are designed to work exclusively with PostGIS. Don't try and put them on top of MySQL, Oracle Spatial, or MongoDB, Elasticsearch, anything like that. These require PostGIS to work and PostGIS only. They create spatial services and allow you to render maps dynamically from your data, right? So we're going to try and show that as best we can through this demo to really kind of give you a sense of what that means. Designed to be super fast, super simple, zero configuration. Your database is your configuration. As I've said before, cloud native, container ready, designed with Kubernetes from the start. They can run both in a microservices environment, or if you got more of a traditional architecture, they'll run just fine in there. Obviously, you don't get the benefits of kind of the auto scaling and the container management framework that something like Kubernetes would offer you. And these are the first two implementations. We'll go a little bit more into that. Before we get into the specific services, wanted to cover at a high level what your requirements are to run these. So for the services themselves, you need some place to run them. That could be a physical server with where you can run the binaries, right? So Linux or Windows or Mac, or you need a server to run the containers, or you need a Kubernetes cluster to run those containers in. And as I've mentioned before, they do require PostGIS underneath. And if I haven't foot stomped it enough, just a reminder, they do require PostGIS, right? If you don't remember anything out of this session except for one thing, remember this: pgtileserve and pgfutureserve absolutely require PostGIS to be running to really be able to do anything. It's not to say you can't download them and spin them up, but if you don't have a PostGIS database to connect them to, they're not going to do anything, right? They are designed to leverage the features and functions found in PostGIS directly, and that's why they can be so small, because they're leveraging the underlying power found in PostGIS, and they're just making it super easy to take an HTTP request, translate it to SQL, pass it to the database, get the results back, and return it back out to your browser. That's what they do. That's the only thing they do, right? And we'll get into a little bit more about the power of that simplicity as we go on here. All right, so where do they fit in the stack? Here's our fun picture from before. They fit right in that middle tier again, but they are super lightweight and they are very purpose-built. So they are designed to do one thing and one thing only. You can see a few of some other potential services we've been considering to roll out sometime in the future based on customer and user feedback. As I said, these are intended to be kind of a growing suite of services under the Crunchy Spatial moniker. But again, all of these are open source. You can go to the Crunchy GitHub repo. You can take a look at the source code. We are going to be pushing out official containers in the near future. So we will have those as well. But if there are any other features, functions, use cases that you think this type of architectural framework and approach would be beneficial to, we would absolutely love to hear more from the user community on what other microservices would be useful to you under this suite. Foot stomped a lot of this stuff, kind of the fundamental benefit of all this. I'll highlight the bottom one here, right? It's processing the data as close as you possibly can get to the data, right? Since it's leveraging the fundamental features found in Postgres and fundamental features found in PostGIS, and PostGIS is an extension on top of a highly powerful and capable database in Postgres, you are leveraging the full capabilities of the database on your data. And so in kind of the modern large data, traditional way of thinking about it, it's always moving the processing as close as you possibly can to the data. Don't move your data to the processing. Can't get much closer to the data than the database that it lives in. So that's kind of the real fundamental power behind all of this you're processing the data where it lives. You're not having to pay that transaction cost of moving it around between a whole bunch of different layers in your tech stack. All right, current features. We'll go a little bit into the current features of both tile server and feature serve. And we already discussed a little bit of the roadmap items. We won't get too much into that. All right, so PG tile serve. So it is designed to dynamically render vector tiles directly from your PostGIS data. If you're not familiar with vector tiles and you want to know more about the history, what they are, Paul Ramsey gave a great talk at PostGIS Day back in November 2019. I've got the link to his talk there. I believe you can also find it off of the Crunchy Data website. Paul goes into a lot of great detail about the history, the motivation, and kind of the current uses of vector tiles. So strongly encourage you to go check out that video. That's not the purpose of today though. Again, PG tile serve, super simple, and that's by design. And by default, and you'll see this as we walk through the demo, any table that PG tile serve has access to is going to be published through a web accessible URL, right? It includes a link to the preview layer, and then it also allows you to do some out-of-the-box filtering that you can append right on the URL, right? So basically, it's an open API that allows you to integrate it directly with your web application and get up and running and not have to worry about configuring your middle tier layer to be able to generate vector tiles. Again, super simple, super fast, and all you need to do to really configure PG tile serve is give it a database connection URL. Once it's connected, it'll take a look at all the tables and it publishes them all, and you can start focusing on the end user application that you want to integrate your data with. Still a little bit more on PG tile serve. In addition to just the base tables that it has access to, it'll also expose out the function layers or any function layers that are there. And we talked a little bit about kind of the inherent functions in PostGIS in the morning session. We didn't really get into user-defined functions. We'll talk a little bit about user-defined functions in this demo. We're really going to be using the user-defined functions more as part of PG feature serve, but that's not to say you can't do some really cool stuff in PG tile serve with it. Again, you're able to do all the processing directly in the database and pre-process the data before returning the tiles back out to the web browser that you're trying to interact with. Again, a lot of power in that type of concept. And Paul also wrote a really cool blog post on how you can do more than just kind of your standard rectangular tiles. He wrote one for being able to do hexagonal tiles in using PG tile serve. Strongly encourage you to go check out that blog post. Really cool, and kind of shows the possibility of what you can do with something like PG tile serve. And then PG feature serve. For those of you that are familiar with OGC standards, PG feature serve puts out web feature services in the brand new OGC API for features standard. It's one of the first ones, if not the first implementation of that new API. And so we're pretty excited about that. And I know OGC is excited about that. We've had a few introductory conversations with them around that. Again, designed to be simple from the start, and same philosophy with PG feature serve. Pass it a database connection URL, and any spatial table that's published or that it has access to will be published through a URL. It includes a link to a preview layer, and again, out-of-the-box filter that can be appended to the URL. And we'll show some working examples of that. All right, so here's what we're going to be going through today. Here's the high-level steps that we're about to get into. We're going to stand up a PostGIS database using one of the Crunchy containers. We're going to pull down and load some demo data that I've got pre-staged in a box location. We're going to spin up PG tile serve. We're going to spin up PG feature serve. We're going to add a local map server just to provide some nice base maps. We're going to stand up a demo UI, we're going to stand up a containerized version of pgadmin for, once again, one of the crunchy containers. And then we're going to add some custom functions to the database to really get that UI working. I'm going to copy and paste this, this URL here into chat, because that is a Google Doc that has the actual steps and the locations and all the Docker commands that we're going to use. So recommend you all go there and have that up, because that'll be a nice reference for you. Go back to present mode. And so before we get into those steps, it's always helpful to know what are we going to build, right? And so here's a screenshot of the end user application that we're going to be building in this. And I can actually take you to the link. And here is the live version of it. And so this is actually up in the cloud. This is a demo server that we've got running. And so this is the basic functionality that you'll see on your local desktop, right? And so it's got a basic UI. This is designed to simulate a scenario where you're the Santa Cruz County fire hazard or fire chief, and you want to manage some fire hazard information for all the parcels in Santa Cruz County. All of this data we did pull down from, sorry, I see a question for chat. Can you put the link here? Which link are you talking about? The link that I'm showing right now?
I put the one before. I missed what you were.
Oh, I'm sorry. I passed it to in a private chat to the last person that was chatting with me. There we go. There we go. That should be better. Okay. So this is actually using all of the features. So it has PG Tile Serve and PG Feature Serve working in the background. And just to kind of show you what you should expect locally on your machine. So you should be able to click on a parcel, be able to do some basic editing of that parcel, change the information, be able to do a spatial query around the parcel. And again, this is all using PostGIS in the background to do all of these queries. And if we have time at the end, I've got a quick example of showing how you could also interact with the PostGIS database that powers this through a different interface, but I'll save that to the end. So again, not meant to show anything in particular about the demo, but just give you, let you know if you've arrived at the right place at the end of the instructions. So with that, now we will hop into the actual demo. So first thing, I will minimize some of these windows over here. Let's see, it looks like most people have made their way to that Google Doc. And I will move the Google Doc over here. So this is what you should see. So first off, has everybody had a chance to download, or does everybody already have Docker downloaded, or does anybody need a little bit more time to get Docker downloaded and installed? How about if you need more time, just drop a message in chat saying need more time. If I don't see any messages, I'll assume everybody is good to go. All right, seeing no messages, we'll assume everyone's good to go. So the first thing I want you to do is, let's go ahead and pull down that the crunchy container. And so I've got the Docker pull command right there. And oh, the other thing I should have mentioned is it would be helpful if you had a code editor locally, something like Visual Studio Code or something like that, to be able to create a couple of files. If you don't have that, I can post some files someplace real quick for you to download and put it into a local folder. But all right, so then I've got this stuff running locally. So where'd my terminal window go? Hello. Oh, there it is over here. All right. So you can see I've already got my my PostGIS database spun up here and running, so I won't be doing that step. So I'll give everybody a few moments here to allow that to pull down. Once you have that pulled down, what you need to do is, and this will probably be helpful if you create just a separate folder, can be on your desktop, can be anywhere, just need to know where you're gonna put this folder. And in a code editor, or if you don't have a code editor and you need me to post this, or you could pass it as part of the command line. I don't have that format laid out right now, but we could do that as well. I'll have to think about that for the next time I do this. But just create a file, call it postgis.env.list, and just copy and paste all of these into that file and save it in the folder. I've got my folder called just FedGeo day, and just drop that in there, because we're going to need to run the next Docker command in the same location where you've got that file located. So I will give everybody a moment there. And if what I'm saying, need examples of code editors. Oh, okay. So Visual Studio Code, I use Visual Studio Code. That's kind of my favorite. There's another one out there called Atom. There's a few of them out there. But yeah, so if you don't have Visual Studio Code, let me do this. Hold on. I'll make it a little bit easier for everybody here. Give me 1 second. No, wrong account. Hold on. All right, so we'll go ahead and do this. All right, so if you need that file, you can go ahead and download it from here and just drop it into the folder that you created. And let me hop back over to the Google Doc. All right. So make sure now we're going to be hopping into the terminal, right? So on Windows, you probably need to do CMD. On Mac, you need to open up your terminal window, right? And so make sure you've navigated to the folder. So if you're not familiar how to do that, you know, it's typically CD space. You know, this one, my folder working directory looks like that, right? So make sure you've navigated to the folder where you've downloaded that list file that I just posted up there for everybody. And then the next step is to copy and paste this Docker run command into your terminal window, right? So you just grab this, and it's not gonna let me do it because I've already got a container running with that same name, but if you do that. So for those of you that aren't familiar with Docker, what it's gonna do here is the Docker run command is going to run the image that you just downloaded. It's gonna give it the name of FedGeo_demo. Please don't change any of these names because I've got the demo running in a very specific way. So if you make any changes to the names, it's gonna cause problems on your side. It's going to take a look at the file that you just gave it with all the connection or all the basic information about the database name that we want to create, the port, the primary port that it gets exposed out on, the mode that it's running as, a user account that we want to create, the password for that user account. So the user is Groot, the password for that is IAM. Primary user is test, and then the root password for the Postgres user is root, right? So very creative. And then it's going to expose that out. So in Docker, you have to explicitly tell it what port you want to expose out. So this step is exposing, it's doing a port forward from the Postgres instance that we just spun up, and it's making it available to the Docker environment there. So that's kind of the format of the Docker run command. So if you do that, mine's gonna choke on me because I've already got a container running named FedGeo demo. So so that's going to spin up and get the container running. It's probably going to leave it running in that active window. So my recommendation is open up a new terminal window, and then we'll start doing the next steps. So the data we want to load into that demo, or into that Postgres instance. And so what you downloaded is actually a crunchy container of Postgres. It's running in CentOS 7. It's got Postgres 12, and I believe Postgres version 2.4 in it, if I remember correctly. So now we need data to put into this. So data loading is typically the most difficult part of any sort of GIS workflow, right? Because no data is ever clean. You always have to do some sort of data conditioning, data cleaning. So we've done all of that for you, and we've just dumped it out of the database, and I put it up in the same box account. So you can download that SQL dump file, and recommend dropping it into the same folder where you're working with the environment list. And once that is fully downloaded, go back to your new terminal window that you opened up, and we're going to copy that, that file into the container that you just created, right? And so this is getting all into how Docker works, not really into anything about how Postgres or Postgres works. So this statement will copy it from your local file, wherever you downloaded it, right? So you always have to be in the folder where you're running these commands, where you've stored the data, and it's going to copy it into that container with that name, and we're going to drop it in the temp folder. So I'll give everybody a chance to do that. Once that is done, we're actually going to log into the container. And so we're getting a little bit into command line space here. So if this is, I tried to make it as simple as possible for you, but if this is a little intimidating, feel free to stop me and ask questions. Again, this is all very Docker specific. Yeah, if you don't understand Docker too well, you know, don't get too stressed out about it. Yeah, we'll work our way through all of this. So once you've got that copied into the container, let's actually log in, and here's where I will actually bring this up so you can all kind of see what you should be expecting. So this is actually going to log us into the container, and you can see we're actually working in the container now because my prompt changed, right? So now I'm working in Bash, and we're going to change into the temp directory, right? So now you can see we're actually in the temp directory. Oh, actually, here, let me back up. So this is what it should look like. If you do an ls command in the container, you should see these, and you can see we've got the temp folder here. So I'm going to change into that temp folder, list the files again, and you should have something that looks like this in that folder. And so once we have that, once we know that that file is there, we're going to use our psql command line, which is, that's actually a Postgres tool. And we're going to load that data into Postgres. Now, this is already a SQL dump file, so it's already in a format that Postgres knows how to handle. We're going to tell it where to connect to, right? So we're telling it localhost, and this is localhost in the Docker network. So it gets us, we're on a network, inside a network, right? So it's like Inception here. And we're telling it what database we want to load it into. So we created that database as part of our previous step, right? As part of this environment list file, the PG database, right? We gave it the name Fire Data here. And we're loading it as the Postgres user. So if you do that command, I'm not going to do it because all the data is there and it's going to error out on me, but that's going to spit out a whole bunch of SQL and it's going to load a whole bunch of data into your database. And that is actually what's going to populate your database. So we can move on to the next step. Checking chat here, see if there's any. You got a request for pass. Oh, yes, I'm sorry. Okay. If you get requested for the password, type in root, right? So root is the password for Postgres on this in this database, and so that should let you import everything. I didn't think it was going to. Oh, it's strange that it did, but if it does prompt you for password, the password's root there, right? And so now after that, we are actually going to log in and just take a quick look at the database, but we're going to log in as the user Groot. And remember, the password that we created for Groot is IM. So if you actually log in as Groot, type in the password. So now you can see we are actually working inside the database. So we went from working in Bash in the container to now working inside Postgres. And so if we list out the tables that we're on right now, so you can see we've got, we are actually in the fire data database. You can see we've got assessor parcels, we've got a sequencer, we've got county boundaries, we've got facilities, fire service areas, high fire hazard areas, a streets table in there, and then just a test table that we have in there before. And let's see. And you can also see the other databases that we've got in there. So we're working in the fire database. There's obviously a Postgres database and then a couple of default databases there. But so really there's only one database that we're working in there. All right, so that's just to verify that data is actually loaded. If you don't see anything like that when you do a /D to get the tables, let me know. Let's see. So yeah, logging into, yes, yeah, for this step, the password's IM. Appreciate the crowdsourcing of support as I work through this example. All right, so to get out of this, we just do a /Q. That's gonna exit us out of the database, but we're still in the container, right? And now we also want to get out of the container so we can work back in our local environment. And so we exit out of the container, and now I'm actually working back in my local machine environment. So far, all we've done is we've stood up a Postgres database and we've loaded data into it, right? So that's step one, check, cross that off. So now, here's where we're actually going to start spinning up PG TileServe and PG FeatureServe. But first off, we do need to make sure if you've only got one container running, this all should be correct, but we do need to find the IP address for the Postgres container that you just created. So what we're going to do is we're going to do a Docker inspect. And this is all just because of working with things locally. If you're doing this in the cloud, you would take a completely different approach, but we're doing it this way because it was the easiest way to kind of demonstrate some of this. So if we do a Docker inspect, it's going to spit out a whole bunch of information, but really all you care about is this right here. And you can see it even changed because I think I have another container running on my machine that I spun this up in a different order. So what you want to do is yours are going to be probably different. So grab this IP address and you're going to copy this whole statement here, right? And oops. And I'm going to go ahead and if yours is 172.172.17.0.2, just leave it as is. If it's not, obviously change it. So I'm going to go ahead and paste this in here. I'm going to go back and make one change. And so the reason why we're doing that is, like I said, we need to be able to pass a database connection URL to PG FeatureServe. So we're spinning up PG FeatureServe here first. And so we need to tell it where to look. And this is a bit more of a uniqueness for creating this all locally in Docker. Oh, yes. And Paul's providing some good good commentary in the chat as well. So make sure you're reading that. Yeah. Okay. So to be able to allow it to connect to the database, normally, you would use something like localhost or service host in Kubernetes. Because Docker, well, I'm not a Docker expert by any means, so this is how I know how to do it. If there's a better way to do it, I am all ears, but I know this way will work for this demo. Everything else, even if you don't have this, this container downloaded locally, Docker is going to look locally on your machine, say, I don't have it. It's going to go up to Docker Hub. It's going to find that. It's going to pull it down for you and spin it up. So you can go ahead and do that. And you should have something like this, right? So again, it's PG feature serve, serves it up on port 9000, so we had to expose that. And since I already had it downloaded locally, it found it locally and created it. It may have told you couldn't find it locally, so it pulled it down for you automatically. And now what I can do is I can hop into, and please do this, make sure that it's actually running on your system the way it should. So if you go to localhost 9000, you should see a screen like this. And so as I said at the outset, it exposes all of the data that it has access to. So all of those tables that I showed you before, the parcels, the boundary, facilities, service areas, streams, streets, all that stuff, that is now being served out by PG feature serve. And so you can do a basic preview, right? And again, this is an engineering UI. It's not the flashiest UI. This is basically just to make sure you're getting data returned back to you. And we're going to put it in a much cleaner interface. But what I do want to show here is when you click on this, you are getting back all of the table attribute information, right? So it is exposing back all of the information found in that table for you. So that's pretty powerful. And you'll see it does the same thing on PG TileServe in a minute. Now, just because it's returning all of this information through the service doesn't mean that we're going to actually use all of this information in the end UI. And we'll show you that towards the end here. All right, so hopefully all of that is working for everyone. And you're seeing a very similar view on your end. And again, I am working all locally, localhost 9000, right? And if you actually wanted to look at the JSON, you can see the JSON. Yay, love JSON. So pretty. All right, jump back to the collections. And as I said before in the overview, it also exposes the functions. Now, apparently that's not working for me right now. Not sure why that's not working. Hopefully that doesn't mess up my my version of the demo. We shall see. So I think that's just maybe a glitch on my side. I always got to love live demos. Oops, where am I going? No, I don't want that. There it is. Okay. So now that we've stood up PG feature serve, let's stand up PG TileServe in the same way. So again, grab your Docker run command. Again, make sure you're changing the IP address to the one that you want there. I got a permission denied. I'll have to take a look at that. We'll see. Don't know why I'd be getting a permission denied. We'll see. All right, so same thing. Now PG TileServe serves out on port 7800. So to verify that it is actually running, we're going to hop back over here. And you can see now we've got a live PG TileServe instance here. And again, we can take a look at the previews, and this will take a little bit longer. And because there's a lot of parcels, tends not to render too well on the engineering UI. But again, you can see we can click on any one of these parcels. We get back the full attribute information that's presented in the tables. And again, because we have access to this doesn't mean we're exposing it all out through to the end user. But we do have access to all of this stuff. So now, however you want to, whatever information you want to expose out to the end UI, you have that ability, but you don't have to, by default, expose it out through your end UI or your end user UI. Okay, so let me hop back over here, check chat, and I don't see any questions. Okay, good. Okay, so now these are providing out your locally hosted data in web in vector tile format and in web feature service format or in feature format. And it's always nice to have kind of a reference base map to display it on. So I have pushed up a local map server. This one admittedly is a little bit bigger, so it may take a little while for you to download. But it has all of the base map tiles for the region that we're looking at in. So go ahead and do your Docker run there. And I think I actually have that running locally. Let's see. Yep, I've got it running locally already, so I don't have to do that. Oh man, that's been up for 4 days. Probably should have turned that off a while ago. So I'll give everybody a moment to do that. And then once that is, once that's downloaded and spun up, and you should be able to go to localhost 8080 and you'll see something that looks, or it should look like this. And so you can see it provides back a bunch of different styles here. I think we're using the OSM Bright style, but if you wanted to, you could change the, well, actually you can't because you'll be downloading a pre-baked container, but you can see now you're able to expose out a bunch of different base map styles, all for the Santa Cruz County area. So that's the container that just got spun up with that step. And now we're going to pull down the UI that I showed you earlier that we've got running in the cloud. And so if you do your Docker run and of that container, this serves out on port 5000. So you'll be able to go to localhost port 5000. And since I already have it downloaded, it spun up for me pretty quick. But again, this one's a slightly larger container. Oh, question. Are the tiles cached? No. The tiles are not cached in PG TileServe and PG FeatureServe. As I said, the tiles are dynamically generated, so there is no cached layer in here. Other vector tile solutions do provide a cache. That is something we have talked about and we're thinking about, but it's not something that is implemented currently. There are other architectural ways you could introduce a cache into your overall stack, but the power of having your tiles dynamically generated, which we will see when you go through the end UI here, is any changes made to any changes made to the underlying data are immediately reflected through every view that database feeds. So there's no tile cache to have to regenerate. There's no caches have to be pushed up to any web servers anywhere. So your data is always live. If you have a data set that doesn't change very often, maybe that's not a compelling feature for you. But that's kind of the main benefit of using these versus some of the other existing solutions. And yeah, Paul's putting a lot of additional great detail in chat for you. So if we go to localhost 5000 now, you should see this. And you can see it looks exactly like the live demo that I was showing you earlier. Now, if you actually go and click on your UI, this is wrong, I don't want this one. So if you actually click on the UI, what you are going to find is this functionality should not work for you. Since I already have the functions in my database, this is actually working for me. But if you click on the parcels, you will not be able to select them. You won't be able to do the searches, and that's because we have not actually created the functions in the database itself to enable this. So in kind of your typical web developer UI or web development type pattern, a lot of times that select and search would be implemented in the UI itself. So your search queries, your parameters, all that stuff would be embedded in your end user UI code. So in this case, this is written in React, so that would be all bundled into the React code itself, and there's no reusability, no portability of that code. By using PG feature serve and user-defined functions in the database, we're going to actually create the functions in the database, expose it out through PG feature serve, and then that will immediately enable the feature or the capability in the UI, but also it's now exposed out through a standard API that you can reuse in a variety of different user interfaces. So you're not tied to just that user interface. So it's doing the work once in the database, not having to constantly recreate that functionality in a bunch of different UIs. And so to do that, we're going to move into the next step in the Google Doc here. And so to do that, we've worked a lot in the command line right now, but a lot of times folks like a prettier user interface. And so we're going to set up a containerized version of pgadmin 4 for you. And again, here's that environment or that env list file. I will go back to my Box account here and drop the URL for the other file that I put up there. And go ahead and copy. So you can download that env or that list file from there. Again, put it in the same location where you've put all your other files. Back over to where'd my Word doc go? There we go. Once you've got that downloaded, and now we're going to hop back into the command line one more time. Go ahead and grab this this Docker command, and this is going to pull down the pgadmin 4 container, and it's going to grab that environment list. And so you just take note, the default, the admin email is going to be training@training.com. Obviously, it's a bogus email address, and the password for it is going to be training. So when you actually go to localhost 5050 test, it's going to prompt you for an email address and password. Use those to log in, and then there is a new server flow. So where do I have my instance of pgadmin? So once you have that up and running, you can go through a add new server workflow, which will be up here file, or no, where is it? I don't know how to do this, really I do. Okay, there we go. Right click on the server, create new server. Up here, this you can give it whatever whatever name you want, because this is only for your own local environment. For here, this is actually going to be the IP address again. So for me, it was 172.17.0.3. The port, maintenance database, Postgres username, Postgres. So you actually do want to connect as the Postgres user. The password for that is root, and then you should be able to save that. I'm already connected over here, so I'm not going to do it again, but so that'd be the new server workflow. And once you have that up and running, what you can do is we're going to go to our Fire database, and we're going to go down to, we're actually just going to open up our query tool here. So again, right click on the Fire database, query tool, it's going to open up a window like this. And I won't go into all the detail behind, here we go, behind the functions that we created. But so if you, from the first create schema statement all the way down pretty much to the end here, just go ahead and grab that entire block of code, right? So that's all SQL. And we're going to go ahead and create the first thing we're going to do is we're going to create a new schema where that, that PG feature server is going to look at. And then we're going to create the functions that it needs to actually make the UI work. And so we're going to hop back over to PG admin. And if you paste that in here, it's probably going to error out on me because I think all this stuff already exists for me. And then you hit the little run button. Helps if I refresh. Why is it down? Disconnect from that one. It's a problem with being connected to too many servers at the same time. So this should work for you. Of course, I've got a conflict somewhere in my system, but hopefully this is actually working for you because it worked for me earlier when I ran through all this, but I did something different between then and now. So let's see. No, that one. If anybody's running into any problems on this step, let me know, but it should be working for you on a clean system. And then once you've done that, you should be able to go back to your UI, hit refresh, make sure, actually, so here's where you should be able to go back to, first let's go to PG feature serve because now you can go, what in the world? What's going on here? Do I have too many conflicts going on? No, that's all working fine. Not sure why that's not working. But, so obviously my local machine, and again, here I was thinking all of you were going to have more conflicts than I was because I ran through all this before. But so now you should be able to go back to your UI and all of this functionality is working. And so now I'll explain a little bit more about what's going on behind the scenes here. So when you actually click on this and you change it and hit save, it's actually going to go and it's going to save that change directly back to the database. And because it's saving it to the database, now it is available to all other users of the database in real time. And so the real power of that is there's no version control that you have to worry about between different shape files. You don't have to worry about any sort of lag time in terms of, oh, I made this change, but it's not going to be live on the system for 30 minutes, an hour, next month when they push all the updates. It is live, it's real time, and both other administrators or analysts, as well as consumers of that data, will see it reflected in real time. All right. And so to kind of hopefully show in a little bit more context the power of that, let me make sure I've still got my port forward going here. Yep. So I'm back out in my web-based one. And so here's my web-based demo. And so you can see, select the parcel, I can make the change here. And again, it's making an update directly to the database. But if I'm only looking through one UI, that really isn't, it's a whole lot of, trust me, it's actually working. It's hard to actually prove it, but what I also have running on my desktop is I have a desktop client called QGIS. So for those of you in the GIS space, yeah, you're probably familiar with QGIS, or at least have heard of QGIS. Whoa, there we go. And so yeah, make sure that's there. All right, so if I bring my QGIS desktop back up, you'll see, so here's the parcel I selected, and then on QGIS, here's the same parcel. And if I bring this over and slide all the way down, it's probably gonna be super hard for you to see, but flood zone, here we go. So fire hazard, right? So you can see it says fire hazard. Well, what if I'm an analyst working on my local desktop, but I want to update that database? Well, I am actually connected to that web-based database. So again, that database is not working on my local machine. It's up in a cloud-hosted environment. So I can go ahead and I can edit the feature form here. And now I can scroll all the way back down. District. Sorry, I'm sure this is fascinating. There we go. So now I can make a change and I can hit OK. And so now that's actually making the change. And I'm going to hit save. And so that's actually saving it up to the database. And because I'm on DSL and I'm trying to stream video as well as audio, it took a little while, but that was actually pretty responsive. So now I've actually updated that attribute. And if I go back over here, so because I haven't refreshed my view, you can see it's still green. But if I refresh my view, and I go back to my fire hazard classification, maybe it didn't push it up yet. Did it not save? Did I lose my port forward? Something happened. It didn't save up there. Well, you know, it is a Friday and apparently my demo just doesn't like me today. Yeah, for whatever reason, it did not save that change. You can see it wasn't actually, let's try that one more time. And we're gonna save the layer edits. So now that should have, we'll turn off editing just to be safe. So now that should have pushed it up. Let's try that one more time. There we go. There, now it worked. So you can see that feature is now changed, and I didn't change it on the UI. I was able to change it through QGIS. So it kind of gives you a sense of the different types of workflows and the different different ability of or the power of being able to do a database driven workflow versus kind of a shapefile or file geodatabase type workflow where you're constantly pushing files around. So, and let me jump back to my little script here, see if there's anything else I wanted to cover. All right, so yeah, now we've made it all the way through the little script there, and so you can see the majority of that time was actually working in Docker, was getting the container stood up, loading the data. To actually get PG tile server and PG feature serve up and running, it was two Docker commands, right? So that's how lightweight they are. There was no configuration you had to do aside from passing it the database connection URL, right? There's your PG tile server and PG feature serve. And they give you a kind of a nice engineering UI to do a basic inspection of your data. And you can see, so we also have a streams layer that we could add to the UI if we wanted, but we chose not to for this use case. We also have fire hazard areas. Yeah, we have access to all of the geospatial data in PostGIS. We just chose not to expose it out through our UI. And so a couple of things to note. One, obviously, as soon as you put PG tile serve and PG feature serve on top of your data, the data is exposed out. We're not putting in any sort of authentication, right? So you want to make sure you're very, one, you give PG tile serve and PG feature serve only the permissions and access to the data you want to expose out, right? So you definitely don't want to connect to it as a super user, because that would open your database up to all sorts of bad things. And also, you probably want to put some sort of authentication mechanism in front of these endpoints. So, some type of OAuth identity provider, something like that, some sort of API gateway to manage that. And then, as Paul mentioned in chat, if you're looking for caching, you can put some sort of caching layer as part of that step as well. So they're designed to be simple. They don't add a whole bunch of bloat, a whole bunch of overhead to your workflow. They're meant to get you up and running with vector tiles and features as quickly as possible and as efficiently as possible. And yeah, and so like I said, they're the first two out of the gate under the Crunchy Spatial moniker. We are definitely looking for feedback, and yeah, so at this point I will pause and see if there's any questions, comments, and we can also start getting into the next combined session, which is the Ask Me Anything for Paul, which obviously there have been some questions already through chat, and Paul's been responding to those. So thank you very much, Paul. I appreciate it. And so for the Ask Me Anything or even the question comment session now, you feel free to either come off mute and ask your question in real time, and we can have a conversation, or if you want to write it out and post it in chat, we can do it that way as well.
Hey, Adam, this is Dennis. I just got a little bit of feedback for you on this session. First of all, thank you very much. You were very detailed, and you kind of flew through all this stuff pretty quickly. I think for the amount of information that you presented, probably a session that was twice as long would be good. And then also too, I'm still downloading like all of the Docker instances that you gave us to install. I'm working in a rural area. I don't have that great of an internet connection here, so I wasn't able to keep up real time with the commands that you were running. So maybe in the future, it might be good to kind of post some instructions on like what you might want to get set up ahead of time, so that you come into the session, I guess, with more of this stuff installed. But
yeah, I appreciate the feedback, Dennis. Yeah, and so I feel your pain on the rural area and poor internet. So I was hoping to post a prerequisite slide, but in full disclosure, I actually didn't get all this stuff pushed up until yesterday, because I too live in a rural area with incredibly low bandwidth. So I actually had to drive to the neighboring town to be able to upload all this stuff. So my apologies on that. And so we are going into the Ask Me Anything session with Paul. Feel free to continue working through all of this stuff, and if at any point you run into a problem, hit me up through chat in a direct message or something like that, and I'll try and work with you as well as I can on that. And the Google Doc will be up there. You can feel free to go through all this stuff at your own pace, as you will, later on as well. I appreciate the feedback though, Dennis, and my apologies. I was trying to be a little bit more prepared, at least a couple of days in advance. Just didn't happen.
Yeah, no worries and no apology necessary. I do have the recording here of the screencast, so I'm planning to go through that later on, kind of at my own speed, and just make sure I can do everything that you just demonstrated. So thanks again.
Yeah.
Yeah, I think don't Crunchy has a learning page. I wonder if you have this or something similar on there as well.
We do not have anything on PG TileServe and PG FeatureServe yet, but that is on our to-do list, and hopefully we'll get that up in short order.
Okay, I'm kind of in the same boat as Dennis. I didn't worry about the Docker because I had it on my computer, but when I tried to open it, I had issues and problems. So I know people tend to talk very fast, like myself sometimes. So, but I don't have a problem since I recorded it. I figured, I could go down later on, do my pace. So, but this was really good. I thought it was, for experienced people, it's quick and just right. For beginners, it's probably a little fast. And so, but thank you.
Okay, good feedback. Yeah, so this is the first time we've done anything like this around these two services. So this is a slightly new format for this. So I appreciate all of you being guinea pigs on this this format as well.
Hello, this is Santo. I just wanted to ask if whether on a production environment, is it recommended to use the containerized environment without deploying Kubernetes, in absence of knowing about how to deploy these Kubernetes? So, like just using Docker containers.
So in a production environment, probably, yeah. That's kind of a loaded question, but I'm gonna answer it with the super simple, oversimplified answer of no. I would not use just Docker to run your production environment. Maybe Docker Swarm, but that even comes with its own complexities. If you're considering a containerized approach, then you probably want to invest in a Kubernetes platform. We're close partners with Red Hat and OpenShift, but there's VMware Tanzu, there's Rancher, there's a lot of managed Kubernetes platforms out there that that do a lot of the work for you. The service that you saw, like I said, we're just showing how to use them in Docker, but they will run just fine outside of Docker using native binaries. And so you can go check out the GitHub repo, crunchydata.com, or not crunchydata.com, but github.com/crunchydata, and check out not only PG TileServe and PG FeatureServe, but all of our other projects out there. And both for TileServe and FeatureServe, there's a lot of great documentation on the repos as well on how to do it outside of a container environment.
Okay, thank you so much.
Kubernetes is, it can be a complex learning curve. For production, some kind of orchestration environment is definitely recommended, but Kubernetes is not the only one. There are other ones like Nomad or Docker Compose or Swarm, like Adam said. So some kind of orchestration environment for production. That said, it feels like Kubernetes has sucked up all the oxygen in the orchestration room. So if you're going to spend the time learning an environment, you might as well spend the time learning one where you can reuse your knowledge in other places. Yeah.
Okay, that's good to know. Well, I had another question. With the future possible PG pace map serve, would you be like replacing the map server workflow of this whole stack?
No, definitely these are very orthogonal concepts. I like to think of maps as being made up of two different layers, the base map layer and then the thing you care about. And the problem for any application is you always need a base map layer because you can't contextualize the thing you care about without a base map. So you can see that, the engineering UI for our PG tile serve, it includes a base map. Even though we're only spitting back features from the database, we still need a base map so we can see where the features are and make sense of them. So
Yeah.
the base map server is really about spitting back proper base map tiles that can then be rendered on the client side. And then the tile server, it's specifically for that live data you care about. So it does things that the base map doesn't do. It serves live data that's changeable, whereas the base map server, the expectation is the tiles are baked ahead of time. They're not being rendered on the fly. They're not being pulled out of the database on the fly. It's just a great big cache of tiles, which it feeds back to you. So,
Yeah. Thanks.
no problem.
So Paul, I'm going back through some of the chat here, and we'll get into your session now. So I missed an earlier question, but so here's kind of a question specifically related to PG tile serve and PG feature serve, and you look like you answered it in chat, but I think maybe a quick recap verbally would be good. Deploying this in production, what are some recommendations for deploying these two in production?
Sorry, I missed I was reading the chat, and I didn't hear your words. I thought you were going to answer the question.
So I think you did answer it, but we'll just kind of recap for recording posterity, if you will.
Right.
So there was a question: deploying such a stack in a production environment. What are the recommendations, in particular, with regard to PG tile serve and PG feature serve?
Right, and then that sort of comes to the question of what do you mean by production, and what do you mean by recommendations? The main thing to note about the tile serve and the feature serve is they're both really small, and they both do very little. So you will have to generate a lot of load on them to be able to worry about scaling them. I mean, they're also really simple and stateless. So from the point of view of deploying them into a cluster, turn them on and giving them an auto-scaling rule and forgetting them, it's probably not the worst thing in the world. What will happen is more load comes in, is you'll generate more load on your database. So the main thing to think about when you're deploying one of these things in production is how much load are you willing to put against your database? So having read replicas available on your database is important, so that the database doesn't get overloaded. The other thing is to recognize what your level of, what the word I'm looking for, is how live you want the data you present to the outside world to be. Because the number one place where you are going to get loading issues is lots of people coming in, and they'll almost always be looking at the same thing. And that's where some kind of caching strategy will make a big difference. So having a cache in front of the tile server in production is probably a useful thing. It doesn't have to be a cache that holds stuff forever. It doesn't have to hold a tile for days. A cache that holds a tile for only a minute or 5 minutes will keep a large spike of load from crunching the database. So thinking about the caching layer when you go to production, I think, is a big deal, because it is possible to generate a lot of load on the database. But it's really easy to stop the load just by having a really thin cache layer in front. So I guess the main things for production are, one, be prepared to read scale your database. So read replicas, important. And then do have a HTTP cache in front of your tile server and potentially your feature server as well, so that repeated queries don't come back and hit your database twice.
Awesome. So moving some questions from earlier this morning. So when is it recommended to store, and so this is a PostGIS question versus PG tile serve, PG feature serve. When is it recommended to store your data as geometry versus geography?
Right. So the world is flat as far as I can tell. And if your problem fits into a flat space, then being able to work in geometry has a whole bunch of advantages. In geometry, the shortest distance between 2 points is a straight line. In geography, the shortest distance between 2 points is a great circle arc. And all the calculations involved in geography have to take account of the fact that all the interpolations between segments are great circle arcs. That means it ends up doing a lot of spherical math for things like calculating distances, calculating whether shapes intersect, whether points are contained in polygons. They all involve a lot of asking questions like, how far is this point from this line, which is a point to arc distance, which involves quite a few trigonometric functions, as opposed to how far is this point from this line segment, which is simple Pythagoras. If you look at the algorithm for distance on a sphere, which gets called constantly in geography calculations, you'll find that it has 5 transcendental functions and 2 square roots, whereas the planar distance in Cartesian space has just 1 square root. So it's immensely more computationally expensive to do work on the sphere. So if you can avoid doing work on the sphere, avoid doing work on the sphere. The times you can't avoid doing work on the sphere are when you have data which covers the whole world and you're going to be querying it across the whole extent of the world. That's really what it comes down to from a sort of straight up. If you can get away with using geometry, use geometry. There are folks coming in who are learning for the first time who find it hard to grok planar projections initially. And sometimes, for learning purposes, I tell them, oh, just use geography. But in terms of a real production system that's going to be doing real work and doing lots of calculations, the extent to which working in a decent planar projection that makes sense for the data simplifies everything and makes everything faster. If you can get away with geometry, use it.
Cool. So a question that just got dropped into chat, and then John, I'll jump back to your other question. I'm not going to let you occupy all of the questions right now.
Come on.
So from Dennis, he says, our Postgres database stores sets of GeoJSON that are owned by different accounts within our system. This data gets stored in Postgres in 2 tables, feature collections and features. Is it possible to have PG TileServe and PG FeatureServe scope their data access to a set of features and not the entire features table?
All right. So yes-ish. The way that TileServe and FeatureServe control access is not through any configuration on the TileServer or FeatureServer, but again, leaning on the database. We try to keep everything we can about how these systems work stored in the database. So the database has access controls available. You can restrict access to particular tables by only granting select to particular users. And Postgres has, in addition to object level security, that is like tables and functions and views, it also has row level security. So if you wanted to restrict the tile and feature servers to particular rows in your tables, you could set up row level security policies that only grant access to the rows that you want those users to have access to, and then only let the tile server and feature server connect with those users. And that would restrict them to just a particular set of features, not the entire table. And it would do it using the standard access control mechanisms of the database. Sandili, would one be correct in saying this provides additional approach to a platform like CartoDB? Yes, assuming you're referencing the previous question and answer. Yeah, CartoDB gives you 1 instance per organization, or sometimes 1 instance per user. And within that organization, you can have multiple users. Users are segmented by username. The access control is by object. That said, while the UI and sort of standard APIs of Carto all expect you to only use object level access control, and all the UIs for things like sharing an object with multiple users use database level access control at an object level. At the end of the day, they are using the core database access methods. So you could probably go in and directly manipulate the grants to provide row-level security in a Carto instance. You just wouldn't be exposed to the UI. You'd have to do all the management in SQL. Does PostGIS or pgchild have the ability to reduce high-density groups of points? No. So far we have, well, does PostGIS? Yeah-ish. So this is kind of a common problem. You know, I have a table of 10 million points, but I want to be able to look at the whole table at once. And it doesn't matter what your UI is, whether it's Carto, whether it's QGIS or TileServe or whatever. You've got this problem of, on the one hand, all the data is there. In order to show all of it, you have to read all of it and then show it. And on the other hand, the fact that your user interface only has so many pixels, and it's silly to draw all the points on the user interface. You know, 1,000 by 1,000 square only has 1 million pixels in it. So anything more than 1 million objects, you probably don't want to retrieve and draw. You end up, there ends up being sort of a best practice where you build something like a materialized view or some other zoomed out higher scale table that you use across a particular set of zoom levels and then flip to the full resolution at a different level. And you can do this kind of in an automated way in like pgTileServe by instead of directly viewing the table of interest, build a user-defined function that based on the incoming zoom level, either does a query against the overview table or does a query against the full resolution table. So the function provides you the view and the data automatically gets flipped to the appropriate data density by the function. The other way you can do it is just do it in your UI and flip between the high res and low res table at the UI level. In all cases, it's like, you know, once you zoom out far enough, the full resolution data stops being useful. Because you're not really seeing it anymore. You know, polygons are being turned into pixels and that kind of thing. So yeah, no, there's not an automatic way, because the only way to do it automatically is to read all the data and then decimate it. And if the first step is read all the data, that's a big scan for a big table.
So there was a previous question related to Carto again. Do you have any recommendations on improving performance in PostGIS specific to Carto?
There's always ways to improve performance, either in Carto or any other Postgres database. There's never like, there's not a make it go faster dial to turn, because if we've already turned it up as high as we can, and in every release we turn it a little further. And that would be true again in the next release. We found a whole bunch of performance improvements we can make for various use cases. But generally speaking, there are ways to make queries faster, but they are very specific to the data that's being displayed and the query that's being asked. The main thing to do is to find out if you have particular performance bottlenecks that are easy to fix. And the way to do that is to run and explain on your database. And that's not necessarily easy in Carto, because it doesn't give you a great, the UI isn't necessarily great for sort of poking at the database directly. They have, I'm gonna copy it over here. There's an internal tool that Carto and the people who do like consulting using Carto as a platform use to sort of make the view of, let you get a little bit more of an unfiltered or database-like view of the underlying database, because even though the UI is there and it's very pretty, you can point and click and so on, there's an actual Postgres and PostGIS database back there. You can just only access it via HTTP. But since the SQL API is there, I mean, since you can send any SQL you want in, you really do have full access to everything in the database. So early on in my tenure at Carto, I asked for someone to help build this little utility, which has since become very popular among folks who have to do more complex work. It's called CDB Manager, and basically it gives you sort of an object browser store to your Carto account. It makes it easier to run SQL and see the results than with the default UI, and also do things like run explains and see the results. So use that and run some explains and explain analyzes. You might find you're doing queries where the default indexes aren't helping you, because by default it only builds a spatial index and a primary key index. And if you're doing a complex join on other fields, you're not going to have an index helpful. So you might want to manually build indexes for those joins. But you'll at least be able to see what bottlenecks are. and attack the problem with a little more knowledge.
All right, I don't see any other questions in in chat, but so just kind of uh, more of an extemporaneous thought type question for you, Paul. So, kind of given where things are in the state of, you know, kind of modern computing, as well as kind of what I'd call this this growing wave of geospatial awareness in society, like where do you see kind of GIS or PostGIS going in the next year, 2 years, right? Where do you think some of the big improvements or kind of big areas of innovation might be coming down the pike?
I'm not a big innovator anymore. It turns out that most of the work I do is just polishing around the edges. The big changes for us are almost always driven by the core database system. That's when things kind of have big step functions forward for us. So we've done, I think, really fancy work with making PostGIS faster and making it a sort of a faster implementation of geospatial and SQL than most other things out there. But we are restricted to some extent by the core database architecture. Over the last 3 releases, 10, 11, 12 of Postgres, parallelism has come into the core architecture. So our ability to take advantage of multiple cores has gone up a lot. So that means if you pull up a 16 node cluster or a 16 CPU machine and fire up a spatial query and PostGIS on it now, the odds of you heating up more than one CPU are a lot higher. The next big step function, and it's one that is a big deal for geospatial folks because we work with very large data volumes, and because the growing number of sensors out there means that more and more organizations have bigger data volumes. The big change for us will be when we can do sharding, and the planner will correctly do parallel queries across different Postgres shards. So right now, the planner understands the idea of parallelism, but only works in one big instance. Once it can understand the idea of parallelism and understand the idea of a sharded table, so where you have like 1 billion points and you want to do a point polygon overlay, and you put 100 million of them on each of 10 clusters, then when you run your overlay, the planner can say, oh, look at that, this table is distributed across 10 machines. I'll send the appropriate piece of the query out to each of the machines. Queries all run simultaneously on the worker machines that get sent back, and then finally assembled on the controller. That's it's called MMP by some people, massively multi-parallel. It's the sort of the core architectural conceit behind big analytical databases like Redshift or Google Query. And Postgres has sort of been chipping away at all the things it needs to do to have that kind of implementation over the last releases. The parallelism we get in a single node, having that built into the planner, into the execution engine, gets us along the line to being able to send queries off. There's also been a parallel effort on making sure that the foreign data wrapper system in Postgres, which is a tool for allowing you to remote queries from one system to another. You run it on a local system, but actually gets executed on a remote system. That functionality has been getting stronger and stronger and stronger with each release. So it feels like at this point, all of the pieces are in place to be assembled into a true massively multi-parallel cluster system. And it looks like, not for 13, because that's coming out in a few months in the fall, but for 14, there seems like a strong likelihood we'll get our first, at least, not prototype, but demonstrable, workable multi-masters query. And that'll be, I think, a big deal because in the spatial world, the non-spatial people don't get it, but we use just a hell of a lot of processing. And we've noticed this with doing PostGIS development, places where the core team thinks, there's very little cost to an execution step. Like I'm going to run a function. That's really cheap, right? Functions are cheap. I/O is expensive in the world of the core team. In the spatial world, it's quite frequently the reverse. Something like an area calculation on a polygon. Computationally, you're looking at every segment across the whole polygon. So it gets bigger and bigger and more expensive as the object gets larger. The objects are almost always large. You know, the call for a function in spatial can be quite expensive. I don't know where I was going with that. Anyways, I think the quantity of data that we're getting and our ability to process it, those are big deals. One of the places where Postgres and PostGIS have run up against barriers, people said, oh, I want to use PostGIS and PostGIS, but my data set's too large, and I run queries which hit the whole data set. We're going to be able to address that in the succeeding releases, but because the core is getting more functional.
Cool. And so please feel free to jump in with any questions that you might have for Paul, either in chat or take yourself off mute. Otherwise, I've got a few other questions I'll ask Paul to you know, kind of help generate some thought here. So taking a slightly different tack, Paul, what would you know, so one of the things that I'm sure you hear quite a bit, I know I've heard quite a bit in my relatively short time at Crunchy is you know, why PostGIS versus, you know, everybody's adding spatial extensions now to their database. You know, there's NoSQL geospatial extensions, you know, for Mongo, Elasticsearch, you know, and all that stuff. So why PostGIS versus some of these new, cool, modern databases, right?
So we'll cut apart first of all the distinction between the modern databases and the NoSQL databases and the non-NoSQL databases. That's a whole other mud wrestling match to get into. And you know, obviously, I fall on the relational side. I don't feel like the NoSQL databases offer a great deal of functionality in return for what you give up in clarity, expressibility, and data quality in a relational system. More relevant is the question of, you know, what distinguishes PostGIS from, I don't know, BigQuery, which is just a SQL environment with some spatial types, or a partial implementation like MySQL Spatial, and it's twofold. One is breadth of functionality, so pretty much every implementation, and this even includes fairly long-standing ones like SQL Server's spatial implementation. They have the 20 of the 80-20 rule. They've got 20% of the functionality, and to be fair, it does cover 80% of people's use cases. So for people with simple use cases who don't care about other stuff and never think they'll have a more complicated problem to solve. And that's the key, right? I mean, yeah, you're settling for less functionality and you're betting that you'll never need more. And that bet is predicated, hopefully, on some other balancing factor, like I already know SQL Server, so it's not worth it for me to put the extra work into learning Postgres, or my work doesn't let me use it, or there's some other thing keeping you from using the superior tool. But if everything's equal and you have the choice between the superior tool and the lesser tool, I don't know why you wouldn't use a superior tool. There's no performance disadvantage or anything like that. The other reason, which is underappreciated, particularly for folks who are building like purpose-built apps from top to bottom, is the extent to which PostGIS is something which integrates into a much larger swath of software. Third-party tools that talk to spatial databases talk to SQL Server, maybe, Oracle Spatial, maybe, probably, PostGIS, almost for sure. And that's about it. Like, you can't point your ArcGIS at Google BigQuery because it doesn't understand it. It does understand Postgres and PostGIS, so it integrates into existing environments and into third-party tooling way, way more and better. So that there's a virtue to being the industry standard. And that virtue is that it works with all kinds of other stuff, and you don't have to handball the integration. So it does stuff, way more stuff than almost every other spatial database. Well, more than every other spatial database. Oracle Spatial is the only one that comes close in terms of features available, and even it doesn't actually come up to the level of the amount of stuff we do. We just do more analytical stuff. And then it bolts into the third-party ecosystem in a way that all the sort of new fancy NoSQL things don't. What recent feature in Postgres are you most, or PostGIS are I most excited about? Yeah. Oh, Postgres or PostGIS, John?
PostGIS. My fingers got away from me, but
Yeah.
answer either way.
Okay. Well, I mean, I kind of gave that away with Postgres, and the sharding is the key one for Postgres. PostGIS, we've really slowed down on features lately, and a lot of the work that I've been doing has not been directly on PostGIS, but it's been on PostGIS gets a lot of its strength out of libraries that it binds together. So I did not have to write any coordinate reprojection code ever for PostGIS because we use the proj4 library for reprojection. Similarly, most of the difficult computational geometry work in PostGIS is done by a library called GEOS, and that's where I've been spending my time. And my colleague Martin Davis here at Crunchy has been spending his time on writing new algorithms for overlay. So the thing I'm most excited about, I hope it's in the next version of PostGIS. We're in kind of a race with the release cycle to finish off the work on the new overlay code for JTS and then GEOS. I'm working on porting it to GEOS. Martin's working on finishing the algorithm implementations in JTS. They will allow us to do really the same things we're doing now with respect to building buffers, doing geometry unions and intersections and differences, kind of the core polygon and object overlay code. But faster. We found the new overlay code is quite a bit faster than the existing code, particularly as you increase the complexity of the input features. And be 100% reliable, and that's the big difference. The current code is mostly reliable. I would say like 1 in 10,000 reliable, but people do generate geometries which will cause it to stop. It doesn't cause the backend to crash, but it causes the backend to say, "Oh, yeah, that topology, I can't figure it out." And then people have to spend a bunch of time trying to clean their data so they can get an overlay going. The new code will never stop. It will generate a correct result, no matter how difficult a problem you feed it. And that's going to be a big, big improvement. One thing which is for sure going into 3.1 is spatial joins, particularly between large polygons and small things, are going to be much, much, much faster. We did a demo yesterday for a bid, and I did a whole bunch of queries, example queries for them. And Adam then stood up one of these lovely Kubernetes clusters for us to do the demo on, and I loaded the data and pulled my queries over, and the cluster, even though it was running on a machine, like a 16-core machine, and I tested everything on my 2-core laptop, my queries were all running. They're taking a minute to run these reports, and they'd taken less than a second to run on my laptop. I was like, what's going on? Like, what have I done? Is the data different? Is anything different? No, it turns out the versions are different. The stuff on the cluster was version 2.4. The stuff on my laptop is the latest code that I've been working on and committing. So yeah, for particular cases, you're looking at 60 to 70 times speed up. It's going to be a real shock to a bunch of folks, I think, when they run their queries. They're like, whoa, this thing broken? This thing is returning 60 times faster. I wonder if the answer is right. But yeah, it's just going to be that this new performance improvement is going to be a huge one for lots of folks. Is PT FeatureServe going for OGC certification? Eventually. We're not in any hurry to do it. But we probably will once they add it to the site test, and we can run a remote validation. I'd really like to see them certify something that includes write access as well as read access, but we'll see.
So the one thing I'll add to that, Paul, is OGC has already reached out to us about PG FeatureServe in particular, and they would very much like us to submit for certification, sooner rather than later. But as Paul said, we're not in we're not chomping at the bit to do that right now. But we're in conversation with them. So they were quite excited when they saw PG feature serve. I think I mentioned earlier on that it's as far as I know, it's the first implementation of that standard. So
it's a nice standard. From a developer point of view, it's a good standard. It's OGC standards have had a serious problem historically, which is that lots of people write servers and very, very few people write clients. And that results in a low level of relevance to the standard. So until we see here's the OGC feature serve client that we can plug into Leaflet or that you can plug into OpenLayers, so that people can just go fire and forget to get feature access into their apps. I think the impetus to making sure your standards compliant is relatively low until there's a standards compliant client out there that's providing some pull on the standard. The push of writing a standard server is a little lower, but we hope we're standards compliant enough that any client that someone writes will just work. But we'll see.
awesome. Let's see. Do we have any other questions from anyone online? So I guess a question I'll throw out to the. There's one question before we get to that. And this will be a good opportunity for people to kind of respond in chat while Paul is responding to this one. So I'd be curious just to kind of understand the different breakout of industry and potential, general use areas that people work in and that are attending. So if you wouldn't mind just kind of dropping in chat, just at a high level, what industry are you in? Government, private sector, agriculture, oil and gas, whatever it might be, just so we have a better sense of actually who's online and what some potential use cases might be that we could maybe talk to a little bit. So Paul, question that just got dropped in chat: what will be the main aim for PG route serve REST API kind of solution for PG routing?
That's the basic idea. I mean, you could already generate tiles with Postgres and PostGIS before we did the tile server. The tile server doesn't add a lot to the equation. Certainly the hard work is all done in the database and have been written before. There's a similar issue around PG routing. PG routing is great. You can do lots of work in SQL. But when it comes time to fire it up and tie your web app to it, everyone ends up writing their own API and have to write their own HTTP glue. And there's not a lot of glue, but everyone writes new glue every time. So having a bit of a standardized API in front of it, I think would hopefully make it more useful. It's difficult with PG routing though, because deployments of PG routing are so dependent on the data you're feeding it. So it's something we've thought about for routing in particular, geocoding, because these problems are so tightly tied to the data that you want to feed them. And because the people who want to stand up these services often don't care about the data. Like some people are like, oh, we're the city of Boston and we use only the Boston data. But most people are like, I'm building an app and I want to be able to route stuff. The actual source of the data is irrelevant to them. All they want is the routing. As we go through these problems and try to visualize, what the best service would be or what the best containers we could provide for a containerized spatial suite. We keep cycling back to the problem of, what data do we feed it and how do we make these containers usable without making them 10 terabytes in size. So we haven't really solved that to our satisfaction yet.
Awesome. So I see we've got one person here in kind of the consulting field to local government. So in terms of deploying PG tile serve and PG feature serve into those solutions. So, and I'll inject a little bit of my background here, right? So when we released these first two services, I was really excited. My background is all in the DoD and Intel community, where there were a lot of deployments of Arc Server and not an insignificant amount of deployments of GeoServer. and just having understood what it takes to stand those up and configure all the services and stuff like that, and just seeing the simplicity and ease of deploying these type of solutions, I was particularly excited. But so Paul, from your experience, kind of in your career, like how much of the use cases in your experience do you think can be solved by PG tile serve and PG feature serve, and where are some use cases that you think just these two aren't good use cases?
I think with modern web UIs, for people who are building custom applications, it's really hard to beat tile server and feature server. But the reality, and this is the reality that you came out of an NGA and that exists in a lot of large organizations, is that what people are looking for is something something that's not bits and pieces, development bits and pieces, like PostGIS and tile serve and feature serve and Leaflet or Mapbox.gl and React. This is a toolbox of things, but it's just like a bunch of parts on the floor. And without someone to put them together into a particular app to solve a particular narrow use case, they're just junk. They're no good. But at the same time, there's lots of folks who have understanding of the core data of their organization, understanding of how to use some geospatial tools like ArcGIS, and they want to be able to answer questions or publish simple solutions on the web. And that's a place where you need to stick the stuff together into a general purpose tool set. Tools like Carto, like ArcGIS Online, like what's it called? Here, XYZ, kind of fit into that middle space where, the problem of how do I publish something on the web is, well, you hit the file import button and it slurps it up to the cloud, and then boom, you can see a map and you can style it. And now you can share that map with people either as URL or as an HTML embed. That's a really valid web-based use case that someone could build using tile server and feature server if they spend a lot of time on it, but which tile server and feature server in and of themselves obviously do not address. They are very much components, and they're not too useful outside of the context of a much larger stack that solves a business problem. So yeah, there's lots of things that happen on the web that are more generic and don't make sense to take these small tools. That said, and I don't think, and this is just a hobby horse of mine, I don't think we should necessarily think about them being used exclusively for like map-based things or applications that are primarily map-based. There's lots and lots of applications out there that are about stuff for which a map is useful, and where you might want to stick a map, and where a live service that shows the maps in your database can be useful. But the core functionality of, say, a residential tax management system is not necessarily going to be looking at the map. And yet, for a given info page, you might want to have a map. And it's good to have those parts that you can stick into an existing system. Oh, we'll hang the tile server off to the side. We'll stick the map UI here into the web page. Boom, we've got a map. We haven't had to re-architect the whole system. That can be very useful. So small things, purpose-built. It's great for folks who are building enterprise systems. And that's a place where something like a big platform like XYZ or ArcGIS Online or Carto is like, it's big and obtrusive and it's in the way, whereas a small component can be easily added to an existing system.
And so I'll just add a little bit on that that I think I forgot to mention when I was going through my part, but so all of you have access to that Google Doc, and you can do this all on your own. And I would encourage you to go take a look at, in particular, PG Feature Serve and the functions, as well as kind of the preview page there, because what Paul got at there, right, was you can use this for more than just map-based applications, and PG Feature Serve will expose out non-spatial information, non-spatial functions in an API as well, right? So it's an easy way to you know, kind of expose your user-defined functions in your database that aren't returning any spatial information as well. So I'd agree with kind of your statement there, Paul. Like, there's utility beyond just the spatial use cases. You know, so it's really how creative do you want to get. And the other thing I'd also say is, you know, it's not necessarily PG tile server and PG feature server, but it's really kind of the spatial thinking and the power of Postgres and PostGIS underneath the hood. And how do you still use the power of spatial data and spatial thinking in any sort of application, right? So you can use your spatial data, but it doesn't have to return a map. I've got a couple of different demos that return, it's doing a spatial query behind the scenes, but it's just returning the data where, you know, within those spatial bounds. And the best way to return that information may not be on a map. It may be in a table, maybe in a graph or a chart or something like that, right? So, and that's just more kind of, you know, kind of building on what you said there for the folks online. I like to really challenge people to think differently, think spatially about the problem sets that they have, but not necessarily shoehorn it into a map, right? It doesn't always, spatial data does not always have to end up in a map. But that doesn't mean you shouldn't be thinking about how you can best apply it. You know, it impacts our day, our lives every single day in ways that we don't even realize or understand. And so I think there's just a lot of power and a lot of utility in not only a powerful database, but a powerful spatial extension on top of that, even if you don't end up using PG tile server or PG feature serve. So let's see. So I know we've got about an hour left on our time. Well, we got a little less than an hour left, but so if, you know, we don't need to keep everybody any later than they want to be here. You know, happy to still continue hanging out and chatting, but it is a Friday afternoon, and understand, you know, people may have other places they want to get to. I'll throw one more call out there for any questions, anything that we either I didn't cover in sufficient detail during the demo, or any questions you would have for Paul, or any feedback just on the combined session in general. Throw that out there for folks. Either, again, can respond through chat or through just come off mute and chat with us. Seeing none, hearing none. Paul, any closing comments, any thoughts, words of wisdom that you'd like to pass on to the group here?
I think it's great you're interested in PostGIS. I appreciate all the feedback on the tile serve and the feature serve. If you get into using the tile serve and the feature serve in your work, we navigate very much by sonar. We have, and by we, I mean Martin and I, who are the main developers right now, the tile server and the feature serve. We have our professional histories that go back into consulting and solving enterprise problems. And we have our biases around how we think things should be architected and what the right solutions are. But the people who are solving problems right now have the real feedback. So we really dive for feedback. I've gotten some great pull requests and issues on the tile server already. So yeah, your stories about what worked and what didn't, issues you have, they're both projects are on GitHub. Issues and pull requests are open. We really want to hear back from people who are using those pieces of software, because they help us decide where the right place to put our next increment of effort is. So thanks for coming to the session and following along with Adam and taking a look at those pieces. And yeah, join the community and help us know where we should go. And if you're a programmer, help us go there.
Awesome. Yeah, and I'll echo that. Appreciate everybody joining the session today. My apologies for the folks that felt it was a little too quick of a demo. I definitely heard the feedback, and we'll take that into account on a future session. And yeah, thanks for your feedback on both PG Feature Serve and PG Tile Serve and the session in general. And so I'd also say check out our website. There's a lot of great content on the blog post. We've got a great learning portal. We've got a new developers portal. So if you're interested in learning more about Postgres and PostGIS, please check that out. And you can also reach out to us through that as well, through the info page. And I think I put my email address up there as well if you want to reach out and get more information. So with that, thank you, everyone. Appreciate your time, and we'll let you guys get your weekend started.
Thanks, everybody. Have a good weekend.